Welcome, everybody. This presentation is on scaling BigBlueButton with GraphQL. A lot of work has gone into optimizing communication between the client and the server using the entirely new protocol, moving away from Meteor to GraphQL. One of the lead developers on it is Gustavo Trott. And Gustavo, I turn it over to you.
Okay, thank you. So my name is Gustavo. I work as developer in BigBlueButton, and today I'll talk a little about what we have been working last months because we are migrating some components of BigBlueButton to use GraphQL, and our goal by doing it is to improve the BigBlueButton in terms of scalability. So I will talk about some topics that we are considering during this migration. Okay, to start, I want to talk about some problems we have currently because when we try to create a meeting with a huge number of users or a huge number of concurrently meetings in a server, we face some problems. And when you analyze the reports, we could identify that the main cause of these problems was the BigBlueButton HTML service. So we one of the causes it was happening is because this service use the framework called Meteor, and Meteor runs under Node.js. And Node.js has a problem because it's not designed to run multiple parallel tasks, so it's single thread. So even if you have a lot of cores in our processor, it will use only one core. So it was a problem. And we had a workaround that was we run a lot of instances of Meteor. So we could improve a little bit the capacity of the BigBlueButton by doing it. But it has a problem yet because when one user joins the meeting, it connects to one instance. Okay, so we have more instances available. But if you have huge meetings, it becomes a problem in terms of CPU and memory usage. All these instances of Meteor turn out that we use most of the CPU and memory, the capacity of the server. So we wanted to improve this because it was being a problem mainly in terms of, for example, if you want a server that supports a lot of user, you need a really powerful server, and it has impact mainly in terms of costs. So one of the causes to make it use so much resources of the server is because Meteor don't manage very well the how can I say the client connects to Meteor and it uses a pub sub service to receive information. So it's all the time, everything that happens in the server, it's sent to the client. All inserts, all deletes, all updates. So if you have 1,000 users connected and something happened, Meteor will send everything, every action to every client, and it became a problem. It's really intensive traffic of data. So with this problem in mind, we went to the developer summit in Berlin, and we assembled in groups. And one of this group was Tiago, Tainan, and me, and other coworkers, but mainly us were working on only on this during the week. And we had this problem in mind. We wanted to get rid of Meteor. And the question was, what is a more efficient approach for transmitting live data to a real-time platform like BBB? So we are considering some alternatives that we could use to replace Meteor. And at some point, Thiago suggested that you could use GraphQL Live Query because it's very used in this kind of applications. It's a query language, and with this, it would really address all the problems we had. So, but one problem is that we don't have this GraphQL server. So Thiago found this platform called Hejura. And this platform make it possible to have this GraphQL server in just a few days. So it was exactly what we needed. We could really quickly create the server, and Hejura is designed to this kind of scenario. So it was perfect for us. And so we started immediately to work on it. Taina created a client side, a front end client, and I started to change the backend to insert data in a Postgre database with the data of the meeting. And during the week in the summit, we created a prototype, and it seemed very promising. So after the summit, we continued with this idea. Okay, so some points to consider with this new strategy is that now we will introduce Postgre database and Hejura as GraphQL server. And it's good because all the Hejura and these technologies is all optimized for high performance scalability. So it will be much easier to scale BigBlueButton by using these technologies than it is to by using Meteor and Node.js. So it's good for scalability. Other thing is that by using GraphQL as query language is good because it reduces the data consumption. For example, if the client just needs the username and color, let's say, so it can say, okay, I want the name and the color. The client can say exactly which fields they need, and then we receive only these fields and nothing more. So it's really different from what you have today, that the client will receive all the data about some user, even the unnecessary fields. So it will reduce the traffic of data. And other interesting thing about Hejura is that it has a feature that it's live query multiplexing. And with this, if all the clients are requesting the same data, so Hejura will query the database one time and send exactly the same data to everybody. It will broadcast. So it will reduce a lot the CPU usage by querying only one time database and broadcasting the same thing to everybody. So just to compare, this is the current approach we use in BigBlueButton when something, some action arrives in the server, in the backend server. It has a lot of steps until it goes to the client's interface. And now it will reduce the number of steps, so it will be faster and will be lighter. Any action in the server until it is showed to the users. Okay, so I will talk a little bit about the topics I just said. For example, the live query multiplexing. For example, here, let's say we have 3 clients in the meeting, and everybody will ask the same query to Hejura. Let's say ABC. Okay, so everybody say, okay, Hejura, give me the ABC query. This is the query. So Hejura will say, okay, everybody wants ABC. And then Hejura will send only one query to the database, and we receive only one result, and we'll broadcast this result to all the clients. Okay, so this GraphQL subscription is established, and then every 250 milliseconds. It's the default value we set. It will repeat the query, and then, but if the result is the same, Azure will not send it to the clients. But when it have a difference, then Azure will send the updates, broadcast the updates to all the clients, and you keep repeating the query every 250 milliseconds. And another thing that is interesting is that, let's say this first client wants two queries, the EF. So he wants ABC and DEF, two queries. And the Azure will like merge both. Then it will merge the both queries and will send only one query to the database. And then the database will respond with the result, but then Azure will split because it will have the result for the first and the result for the second. Okay, so we have two results, and then Azure will forward the results for this is for one client, this is for another client. But by merging it and sending only one query to the database, it will improve a lot the performance, and it will be lighter and it will be faster. So we have two kinds of multiplexing. One is that join every client that has the same query, and it's also join different queries, so it increases a lot the performance. So this is one strategy that we have been adopting to take advantage of the multiplexing, that is avoid user ID on queries. Let's say the client wants this query. I want the user, the ID, the name, and the color. Okay, so the client will send the query to Azure. Azure will check the variables of this user, and it will say, okay, this user is this meeting ID, he's moderator, yes or not, he is presenter, yes or not, and okay. Then Azure will take the permissions of this user and will append it to the final query. So the final query to the database will be, okay, give me these columns, this table, but I want to filter. I want only the users of this meeting. And what will happen? Everybody in that meeting will have the same meeting ID here. So Azure will identify, okay, everybody have the same meeting ID. So I can send only one query to the Postgres, because if everybody wants the same thing, I will query only one time. And then it will take advantage of the multiplexing. But if you had other strategy that was, okay, but I want to filter by user D, 1, 2, 3. Okay, I want to filter only this for this user ID, let's say. So if you have 1,000 users at the same time querying it, you will have 1,000 different queries, and it will have one time different queries to the database and one time different responses to the client, and it will be a problem. So we avoid always as possible, we avoid to use the user ID in the query, because by doing it, we can use the multiplexing. Okay, other benefits of this new approach we are using is the selective data fetching. By using the GraphQL query language, the clients have more control over the data they will receive. So it will make the application more efficient and better suited in terms of network bandwidth and client-side performance. So I will explain some topics just as example. Necessary fields only. It's a huge benefit that we have now. Let's say we want to render the user list. Okay, what you need to the user list? You need the username. You need to know if he's presenter or not. We need to know the user color. We need to know the user role, choose if it's viewer or it's admin, moderator. So, okay, I just need these fields, nothing more. And then the client can say, okay, give me only these 5 fields. And then in the database, it will return only these 5 columns. And the final JSON that the client will receive will contain only these 5 fields. So it's much lighter than before because Mongo used to send all the fields to the client, and now it will be only the necessary fields. Other example is that, for example, if you are with the chat open, so we have some queries here, the chat list, number of users in the meeting, the users, and the chat messages. But if you click to close the chat panel, then in the second screen, we don't have the chat messages here. So we don't need this information anymore. So what happened? When you close this panel, immediately the Apollo client will send a message to the GraphQL server and will say, okay, you know the subscription with ID 10, stop it. I don't need this information anymore. So the GraphQL server will stop to send the chat messages to this client because it's not necessary anymore. So it's cool because if you are not seeing a component, we will not receive data for this component. Other thing that's interesting is that we have server-side aggregation, and we didn't have it before. So, for example, let's say we are seeing the user list, and a new user join. So, but you can see only 10 users in our screen. Another user join in the end of the list, but we are not seeing. So we don't need to know his name, because if it's not in my screen, why I want to know the name of this user, why I want to know the color, the role, everything. I don't need, because I'm not seeing this user in my screen. So what I will see the number of users in the meeting. It's the only information that I'm seeing, and will change now. So the server will send only the count with the number of users, count 80. So it will change. I will change the number here in the count of users in the meeting. It will be changed to 80. So that's it. Only this information, nothing more. And other thing that continues the previous explanation is that the server pagination. So if I'm seeing only, let's say, I am the first page of the user list, so I don't need the information of the others. The server will send for me only information about these users. But one strategy that we have been using is, it doesn't matter if I'm seeing 10 users here, or if I have a really big monitor and I can see 20 users. Okay, if I have a small screen and I can see only 5 users, okay. But we will always ask the server to send the first 50 users. It doesn't matter if I can see 50 or not, but it's useful, because if everybody in the meeting asks the same number of users, the server will have exactly the same query for everybody, and then the server will be able to use the multiplexing. So it will have only one query for everybody. It will be much lighter for the server. It will reduce the CPU processing. Okay, now I'll talk a little bit about the graphical meter. Why you needed to create it. For example, we are using this platform Hejura, and normally the client would connect directly through Hejura. Okay, so it creates a WebSocket connection and send a GraphQL query. It's the normal use of this platform. But the Hejura has some shortcomings, and we need to fix it. So we needed to create this GraphQL meter. It basically receives the message from the browser and forward this message to Hejura, and then get the response for Hejura and forward this response to the client. Okay, that's basically what this middleware will do. But why we needed to create it? One reason is because we wanted to choose JSON patch. This JSON patch is good to reduce the payload size. For example, if I am with the chat messages open here, I am seeing the last 10 messages, okay? But a new message arrived. Here in the end of the list, a new message arrived. What will happen? The Hajura will send the last 10 messages again, and will include this last message here. But the other 9 messages I already had in the client. I didn't need to receive it again because it was in my screen already. So the only thing that changed was the last message. But Hejura don't have this feature. It always sends the whole object. What we did in the middleware, we compare. Okay, what's the last message the client received, and I compare with the new message. So what's the difference? In this case, we have a new message here, okay, and it's the only thing that the client needs. So the middleware will say, okay, add at this position this new value that is the new message. So the client will receive only the difference, nothing more. So it will reduce a lot the payload. It will be contribute to the overall network efficiency. So it's a good thing for that the middleware will do. Other example, let's say this user is a viewer and he will be promoted to moderator. Okay, so what's the difference? The name will not change, the color will not change. The only thing that will change is the role, because now he is moderator. So that's what the client will receive. The middleware will say, okay, replace this position, this field with the new value that is moderator. And that's all. It's the data that the client will receive. So it will be really, really small payload. And it will contribute a lot to the network efficiency. And here is the other shortcoming of Hejura that we solved using the middleware. That is, let's say, for example, when we have a connection between the browser and Hejura directly, when the connection is established, Hejura check the user permission. So let's say this user is viewer, okay? But Hejura only check the permissions when the connection is established. So it doesn't change anymore. So if the user is viewer when it connects to Hejura, it will viewer forever. Can't change. So it's a problem we have because in BigBlueButton, the permission can change during the meeting. In this example, I have this user that is promoted to moderator during the meeting, but you can have the inverse. So maybe the user has the moderator permission and now he's not moderator anymore. So it will reduce the permissions. So we have to guarantee that this permission will be refreshed. So that's what the middleware will do. So now, when somebody is promoted to moderator, the backend will receive the message, will update the database, and then it will send a message to the middleware, invalidate connection of this user. So the middleware will kill the connection, it will reconnect, and then when it reconnects to Hejura, Hejura will check the permissions again. And then when it checks the permission again, now the user is moderator. And then he will be able to get data that only moderator is allowed. So this connection will be killed and a new connection will be established. And now the user is moderator. In this new connection, he is moderator. Previous connection, he was viewer, but this connection was killed. Now he is moderator. So yeah, this is one thing that the middleware will improve. That is invalidate the user connection when it's necessary. When it is promoted to moderator, he's make the presenter or something, or he's ejected of the meeting. Every time the connection is killed and reestablished. So yeah, that's the main topics I wanted to talk with you, and I hope I could explain it in a easy way to understand. And we have much more to talk about this new approach, but I think this is the main points I wanted to say. And yeah, that's it. Feel free to make questions.
Gustavo, very impressive. I have followed the GraphQL implementation, but I think you brought a lot of the concepts together in a way that anybody who has been working with BigBlueButton can appreciate the improvements that are coming. And I see there's some questions coming through here. I'll do the first one, maybe second one. George, the recording is going to be available probably next week or the week after. We're going to bundle them all together, put them up on YouTube, playlist, blog post, and promote them. And we definitely encourage you to share. There's a lot of good content in these presentations. I'll turn over Danielle's question to you, Gustavo.
Yeah, about Daniel's question, I think this malicious and some DOS attack, you can probably use the middleware to prevent it. We didn't explore these cases yet, but it's a good point to consider. And yeah, it's good that you have the middleware, because if you were relying on the Azure, we would not be able to control this, prevent this kind of things. And now with the middleware, I think we can very easily take care of it. Yeah, I think it will reduce a lot the complexity of the client for sure. A lot of things that were not able to do using Mongo, now the GraphQL query make it possible. For example, filtering, ordering, or aggregation, and a lot of things that is now really easier. So yeah, but for sure it will reduce complexity. And other things, for example, we have an endpoint that show only the user that's talking. So the talking indicator don't need, it just need to show information. It doesn't need to have rules in the client side, because before we had to find, okay, which user, give me the list of users, is this user talking? Yes, so show this user in the talking indicator. And now we don't need it anymore. The server will decide when it should show the talk indicator or not. So a lot of we are moving a lot of the complexity to the server, and it will reduce the complexity and the number of rules in the client side. About benchmarks, we don't have it yet. We just can see it while we are developing. We can feel that the client is lighter, the server is lighter, but we didn't migrate all the components yet. So we are using the old approach and the new approach at the same time. So it make it difficult to make comparison, because the old approach is there yet. We can't remove it. So it will make impossible to isolate both approaches and compare them. But I think soon in the next World Conference, but for sure we will have benchmarks.
I think we're good. Gustavo, thank you very much. That was an excellent talk.
All right. Thank you, Fred.